Hello everyone, welcome to Station Boy. This is the second video in the series of substation protection and control design. Now before going deep into the protection and control design field, we need to have our fundamentals clear. So today's topic will focus on DC circuit fundamentals. Alright, so we have our DC circuit over here and there are three basic quantities that make up the DC circuit. So they are actually current, voltage and resistance. So a circuit is formed when a conductive path allows free electrons to actually move around the circuit. And from basic physics we know that this movement of electrons is actually called as current. Now voltage is actually the measure of the potential energy between two relative points. So the high potential and the low potential, this is voltage. Now when these free electrons or current move inside the circuit, they will face some opposition. This is called as resistance. So current is measured in amperes, voltage is measured in volts, and resistance is measured in ohms. Now to better understand this, it's sometimes actually helpful to think of electricity as water flowing through pipes. So let me just change the color of my pen. Yep. So let's say you have a pipe like this and there is a water flowing inside the pipe. So this flow of water is actually equivalent to current. Now there will be a pressure that inside this pipe that will allow the water to flow from this end to this end. This will be actually equivalent to voltage. So in a water system you actually have a pump that would actually pump water from this end to another end. In electrical engineering you would have a generator. Now this water flow would actually encounter some opposition when it's flowing through the pipe. That actually is called as resistance in electrical engineering. Now in a water system, this pipe is actually used to carry the water in the system. In electrical engineering, that would be equivalent to a wire in which current is flowing. So you see, it's simple to understand when actually you compare a current and water analogy. Now let's say that there is some obstruction or some garbage inside this pipe. So the flow of water is actually going to get reduced because the pressure of the system reduces. That is actually equal to this voltage drop in an electrical system. Now let's say that you have a pipe like this and it breaks. So a lot of amount of water would actually flow, but it would not go over here. It would just start flowing on the ground. So basically there is no opposition to this water flow. This is actually equal to zero resistance. And what will happen is this pump will not be able to maintain this pressure because this tremendous amount of water flowing. This would actually be equal to a fault in a system. And you actually have valves in water system, and whenever there is this leakage, we can actually turn this valve and this flow of water is gonna get reduced and basically become zero. Now this would actually be equivalent to a current and a potential transformer, because what will happen is a current transformer would actually start seeing a lot of amount of current flowing through its primary side, and it will tell the relay that there is a fault, and the relay would actually ask the breaker to trip. And we will go into all these concepts at later stage, but I just wanted to put it out because this way it will be very easy for you guys to actually have a water analogy and compare it with current, so you always remember what's going on. So now coming to Ohm's law. So Ohm's law is actually a mathematical expression that tells that voltage is actually equal to I into R. And I have this triangle over here that can simplify this expression because you can remember the formula. So let's say that you want to find the voltage in this case. So voltage would be actually equal to I, and you just multiply this by R. So V will be equal to IR. Now let's say you don't know the current. The current is unknown to you, but you have your voltage and resistance. So what you do is, let's say this is the unknown quantity. So I will be equal to, and you can see this V divided by this barrier over here. So it would be V divided by R. Similarly, if you don't know the resistance, it would be this V divided by this barrier, and you have your I. So this way you can actually remember or just quickly derive these formulas. So let's see some Ohm's law in action over here. So you have your circuit over here, and let me change the color of my pen. Yeah, right. So in this case, they have actually given you the voltage, they have given you the resistance, and you want to find the current. So the question asks, find the current and what would be the direction of the current, or is the direction of the current correct? So from Ohm's law, we know that V divided by R in this case would be equal to 5 divided by 1 equal to 5 amps. Now coming to this direction, and it is important actually. So whenever you have a circuit like this, or like any DC circuit, you can actually assume a direction of the current. So let's say I assume this is the direction of my current, and if you have a positive value of current, which we have in this case, that means your direction that you assumed was correct. If you have a negative value, that means the direction that you assumed was wrong. So if this would have been minus 5 amperes in this case, then the current would have flown like this, or basically something like this. Second way to remember this is, like whenever you are going from, let's say you assume this direction of current. So the current is entering this minus point and like ending and leaving this positive point. So you are actually going from a low potential to a high potential. So that means your voltage is positive. Always remember this way. When you go from negative to positive, there is a voltage rise. So this V is going to be positive. Resistance will always be positive. So resistance will always be positive. Now the polarity across this, so the voltage polarity across this resistance, now that could be negative or positive, but resistance will never be negative, it will always be positive. So 5 divided by 1 is equal to 5 amps. Now let's say you have this circuit and you assumed this direction of current. So now current is actually flowing like this. So what is happening is it's entering this positive node over here and leaving this negative node. So your voltage will actually be negative. So in this case, you would have minus 5 volts divided by 1 ohm, which will be equal to minus 5 ampere. So you will know that the direction that you assumed in this case, which was this one, is wrong. It would actually flow like this. So you see, it's simple. And in similar way, like in this case, you actually have your current and your resistance. So your voltage would basically be 5 into 1, which is equal to 5 volts. And in this case, you have your voltage and current given. So resistance would be equal to 10 divided by 5 equal to 2 ohms. Now again, let's say in this case, the direction of the current was given to you like this. And they tell you that this is minus 5 amps. So what would happen is, you would come to this positive end, which is the starting end of the current, and go to the negative end. So what would happen? Your voltage would actually drop. So you would have minus 10 volts divided by minus 5 amps. So you see, your resistance will always be positive, 2 ohms. Always remember that. So in this way, you can actually see Ohm's law in action. So now let us see series circuits. So this is a series circuit over here, and there are some basic concepts that apply to a series circuit. The first thing is that current in every component of the series circuit is same. So what does this statement mean? So this means that basically, like when the current starts flowing like this, it does not have any other part to go. I mean, it can't flow over here, it can't flow over here, it can just flow like this. So it starts at 6 amps, it's going to be 6 amps, 6 amps. So in a series circuit, current would always be the same. Important point. Second thing is, the total resistance in a series circuit would be actually equal to the sum of all the resistance. So in this case, your R total or R equivalent would be equal to 3 ohms plus 10 ohms plus 7 ohms, which is equal to 20 ohms. So your resistance is actually going to increase in a series circuit. And the total source voltage would be equal to the sum of all the individual voltage drops. And we'll see a voltage drop in the next slide And this will help you to understand what this point actually means. So you have your series circuit over here. Now, basically what was that C point referring to is that the voltage drop at this point. So let's say you have your voltmeter and you connect between A and B. So what would be the voltage drop? So that would be, now we know from Ohm's law, it's actually equal to V into IR. So 6 into 3 is equal to 18 volt. The voltage drop over here would be equal to 60 volt. The voltage drop over here would be equal to 42 volt. So basically, like if you add this, so 18 plus 60 plus 42, the sum of that would be actually equal to the source voltage. And this will always be true. And this in sense is actually a Kirchhoff voltage law, which we'll see further, but I just wanted to illustrate you like what that point C meant. Now, and like as we discussed in the first slide, the voltage drop is actually similar to that, the water flowing in the pipe and it gets reduced because of some garbage or some obstruction. So the pressure in the system would reduce, which is the voltage drop. Second thing is, as we discussed and as we see, that the voltage drop at different points would be different. Why? Because you have your resistance 3 ohms, 10 ohms and 7 ohms. Now the current is same, but the resistance value is different, so voltage drop would actually be different. So now we come to the Kirchhoff's voltage law. So what exactly is this KVL? And I have this diagram with voltmeter attached, which would make it very simple for you guys to understand. So basically it states that the algebraic sum of all the voltages in a loop must be equal to 0. So this is your entire loop is what they're saying. So they say that if you add all the voltages over here, they should be equal to 0. So if you put your voltmeter between this point 2 and point 1 over here, it's going to read positive 45 volts. Similarly, over here, it's actually going to read 10 volts. Over here, between 3 and 4, it's going to read 20 volts. And over here, it's going to read 15 volts. And I have assumed the current to be equal to 2 milliamperes. So again, from our basic principle, if this is the direction of the current, so it's going from minus to plus. So what's going to happen? Your voltage is going to rise. So you have 45 volts. This is plus and this is minus. So when you go from higher to lower, like this the current would flow, your voltage is going to decrease. So it's going to be 10 volt. Similarly, over here, your voltage would be minus 20. From high to low, again like this, it's going to be minus 15. So basically, if you add this, so this would be 45 minus, this entire thing would be 45. So you would actually get 0. This is what this Kirchhoff voltage law is. That the sum of the voltages in this loop must be equal to 0 and it will always be true. So you see. So now coming to parallel circuits. So this is your parallel circuit over here. Now basic things to remember in a parallel circuit. The first thing that would need to remember is the R total in this case would be 1 upon R1 plus 1 upon R2 plus 1 upon R3. And if you guys calculate, it would actually come out to be 8 ohms. So in a parallel circuit, the equivalent resistance gets decreased. So R total decreases. In a series circuit, it increases. In a parallel circuit, it decreases. Second thing. So now observe over here. If I put a voltmeter at this point and at this point, what would the voltmeter read? It would actually read 120 volt. If I want to measure the voltage at this point, it's still going to read 120 volt. And this will also read 120 volt. So this brings us to an important point. In a parallel circuit, the voltage across the circuit remains the same. You would have 120 volt across this resistor 120 volt across this, 120 volt across this. In a series circuit, the current is same. In a parallel circuit, the voltage is same. So this is what I have highlighted over here. We discussed this, and this is now we need to understand this point, that the sum of all the branch currents equal to the total current of the circuit. So you see, like when you have your R total over here is equal to 8 ohms, and when you use Ohm's law, so V divided by R, you actually get 120 divided by 8, which actually comes around to be 15 amperes. So 15 amperes is flowing in this circuit, and this is basically a KCL, which we'll see in the next slide what this point is trying to highlight. So this point is basically Kirchhoff's current law, which states that the algebraic sum of all the currents entering and exiting a node must be equal to 0. And guys, please remember, I'm going to stress this point again and again. KCL is very important when we'll be studying differential protection. Differential protection is based on KCL. So please make sure you understand this very nicely. So let's understand this. So it says that the algebraic sum of the currents entering and exiting a node. So a node is like this. This is a node where like the current gets divided. So this node has some properties. The first property is this. So let's say you have an arrow facing like this, arrow facing like this. If both of these arrows are actually like facing towards the node, these would actually get added. So let's say you have this A and this as B. So the net thing would be A plus B. If you have a arrow pointing like this and this arrow is pointing away from it, and this is A and this is B, it would be A minus B. Remember this, guys, this is important. So now how do we have the 6 ampere, 6 ampere and 3 amperes? So if you remember, this was 20 ohms, this was 20 ohms, and this was 40 ohms. We apply Ohm's law. So you have 120 divided by 20, which is 6 amps. Similarly, 120 divided by 20, which is 6 amps. You have your 120 divided by 40, which is equal to 3 amps. So initially we had calculated that the current in the entire circuit, the R total, was actually equal to 120 divided by 8 ohms, if you remember from last slide, which was 15 amps. So 15 amps is leaving this circuit like this, which is fine. But at this point, now you see that the flow of electrons or the current actually has two paths, which was not the case in series circuit. But in this case, the current could actually go like this and it could go like this as well. It has two paths. In this path over here, it's actually 6 amperes. So now if I zoom on to this node over here, so you have 15 amperes entering like this, 6 amperes going away from it. So 15, 6. So how much would go away? 15 minus 6, 9 amps. 9 amps would actually go in this direction. Now you could have argued that what if it's this direction? So then if this would have been 15 and this would have been 9, so 15 plus 9 would have been how much? 24 amps, which is not the case, right? It is 16 amps. So the current actually has to leave this node. Now 9 amps is going like this. Again you see 6 amps is going like this. So 9 minus 6 would be actually equal to 3 amps. Now over here current has just, again you see, like this is just one part to go. So 3 amps goes. Now 3 amp enter like this, and 6 amp is entering over here, which is this case. So 6 plus 3, 9. You have 9 amps entering this node, you have 6 amps entering this node. How much is leaving it? 15 amps, which is what we wanted, because in the end the current that is leaving over here should be equal to the current that is entering. So 15 ampere left the circuit from this point, 15 ampere is entering. So I've tried my best to like you guys to explain you that this is Kirchhoff's current law. And again remember, like I'm just going to stress this point again, this is very important because we are going to use this in differential protection, and make sure you understand this KCL. So with this I'm going to end the DC circuit fundamentals. I hope that you like my video, subscribe it, and it will really help you to become a good PNC engineer. Tell your friends about it. They can view the videos. And if you have any questions, put them in comment. So thank you, and you all have a nice day.